Hello everybody, Ambit here. Today we're going to take a look at how exactly to use Git. And we're going to do that by using GitHub. So, step one, let's get GitHub Desktop downloaded. If we just go to Google and type in GitHub Desktop, we can go ahead and follow their download process. It's relatively simple. You download it, you log in. Hopefully you have an account for GitHub at this point. I believe they'd added a new token system. I'm not going to cover that in this video, but if you have troubles with that and like you can't push or pull or something, I'd go Google GitHub token problem or Google whatever error it comes up with. So we're going to assume that you got GitHub Desktop downloaded. So you're going to open it up and you're going to see something that looks like this. So before we get super into how GitHub Desktop works, we're going to shift a little bit over to talking about theory of Git. And to do so, I'm going to pull up handy dandy and trustworthy paint, and we're going to make a visual representation to give you an idea of the core concepts of Git. So, one of the first core concepts that you'll hear about is branches. We can think about branches, as I talked about in the last video, as timelines. So, let's say, for example, these are going to be real branch names that you would see in a real project. The old name that we used to use for the standard branch that you start out with, the singular timeline that your project starts out with, used to be master, so you'll see that in a lot of older projects. The newer timeline name, after for political correctness reasons, obviously, we call it main. So when you first create your project, you'll have a main branch or a main timeline. Well, let's say I have two developers on my project and we want to make some changes, right? Rather than both of us working on the same timeline and potentially collaborating each other's work, we can make two timelines, right? So we're going to branch off of the timeline two times. And well, you need to give your branch a name so that way people know what your timeline is. So we'll call this timeline, and usually there's standards in your company for these names. So usually I would do like feature slash add button, or the other branch would be called bug slash text not showing, or something like that, right? So I create my branch, I do some work on my branch, and how do you do work on your branches? So in order to give changes to GitHub, we have to use commits, right? So those are going to be represented on our timeline by these little circles. If I can make it big enough to move it around. Okay, so let's say these two circles are a bundle of work, right? So to add the button, let's say step one was create button prefab, right? So like in Unity, you'd create the button prefab, and then you would add prefab to the UI, right? So I'd have two, like, maybe I only had 10 minutes on the first day to do the creating of the button prefab. So I bundled that work together and I said, okay, this work happened at this time and here's the things that changed. And then on the second change, I added a prefab to my UI, and let's say that's all I wanted to do on this branch. I'm done, right? Now I would do an operation called a merge, where I basically take this timeline and I shove it back in to the main timeline, right? So all of the objects that are on my timeline will basically be pushed over onto the main timeline, and they would now exist there in order, so that way the changes are applied sequentially, right? So I added a line here, and then the next minute I add a line here, so that way I can still go back and I can see the changes, right? So we've talked about the features of Git that are branches, commits, and merging. The process of doing this merge operation is typically done through a process called a pull request. I request to pull my changes to a different branch. So the most common workflow for this is you would have a master or main branch or a release branch of some sort, right? So the main branch should never get touched unless you're ready for a release, right? So main branch, the only like commits you should have on this is like version 1.0, version 1.1, and so on, right? So you can make a separate branch called, release 1.0.1, and you would merge all your changes into that branch, make sure there's all the bugs are hashed out, and then merge into your main branch. So that way the only thing that ever exists on that branch is a working copy fully ready to go. And the way you do those merge operations again is through pull requests. So we're going to take a look at each of these individual concepts and theories that we've talked about and put them to practice. So we talked about repositories a little bit last time. We're going to go ahead and make a repository. So you can do that by either going to your profile and clicking repositories here. And if she loads, we can click new, or you can go to your repositories and it'll just take you here. So we can go ahead and create a new one, and we will just call this guy my fun Unity project. We can give it a description. Not 100% necessary. We'll just call it a test project for a YouTube video. And the next topic I actually do want to spend a second talking about public versus private. Public is the term that you've probably heard me talk about in the last video, open source. If this project is public, anybody can see the code. They can't edit the code that I own necessarily. They can make a pull request to request a change, right? So let's say I make this cool game that I made for free or something, and people found a bug in it and I haven't touched the game for 5 years. They could request to make a change and I could approve it. Whereas if it's private, only people that I allow to see the repository and the code can see it at all. I would strongly urge you to go public. Git and GitHub know that open source is for the greater good. So if you do a private project, there'll be some features that you would either have to move your project to public for, or you'd have to pay, right? So if you just go public, all the features will be unlocked because you're doing the right thing, right? There are a few instances where you may want a private project. If you have funding for your project and you have proprietary files or art or something that you don't want people to be able to steal, yeah, private project makes sense. So we have a name for our project, we have a description, we have whether it's public or private, and then we have some extra modifiers to our repository down here. So a README file, we'll go ahead and add one. Basically, you can write a long description of how your project looks. You can give people like, here's the structure of the folders, here's how you can contribute, and so on. And git ignores. These are a fun little topic. Have you ever heard of temporary files? I'm going to assume you have. Basically, like, when Unity loads up, it's going to try and like link how, a prefab holds a reference to a material and whatnot. And we don't need to upload that information, right? Because Unity can calculate that. So why should I push it up when somebody can download the project and Unity can figure that stuff out, right? So git ignores are common for most types of projects. So you can see there's tons of different types of git ignores. If we just go ahead and type in Unity, Unity is used often enough finally that they give us a default git ignore. And we will take a look at this later and I'll give you a much further in-depth explanation of how it works. And the last thing is a license. So a license is how you allow the users to interact with your code, right? You can say, you can use my code for educational purposes, but not for commercial purposes. You can have my code, I don't give you a warranty, it's an as-is basis, right? So I'm gonna use the MIT license. It's kind of a standard. It basically says you can use my code as it is, however you want, but I don't make any promises that it will work. So, right, it removes my liability from me, but it still allows people to use it. And we get this last little tip down here. This will set the main branch as the default branch. You can change the default name in your settings. We're going to leave that because I like the name, the main naming convention. So we'll go ahead and create our repository, and GitHub will show us our repository, right? So what is in our repository at this point? The git ignore, the license, and the README. And then down here you have a little expanded view of the README. So I could go in and edit it, and I could say, this is a format called Markdown that allows you to use like symbols to make it look how you want. So if I go to preview, for example, the My Fun Unity project, the hashtag makes it a header, basically, right? So I can say contributing. Please contribute by making pull requests, right? And then we have a commit, right? So we've made we're trying to make our change, and then in order to actually make that change apply, we need to commit. So you can see it can give us a default commit summary. Just update the README. And I'm going to overwrite this just to show you exactly how it looks. So I'm just going to type update the README so you can see exactly how it looks. And then you can choose which timeline you want to commit this to. We're going to commit this directly to the main branch because there's no reason not to at this point. So now that I've reloaded the page, you can see my little change, right? And if we go back to the project, or back to the top level of the project, we were clicked on the file, right? You can see like the little folder structure here where we were in the file. And you can see, oh look, I made a change 15 seconds ago. Well, if we go to this little commits button right here, you can see the history, right? So the initial commit created the project. If we click on that guy, you can see it created the git ignore, the license, and my README, right? And if we go back and choose on update the README, it'll show you exactly what lines have changed. This is one of the reasons why Git is so powerful, or most version controls do this, but I'm just going to keep using Git as my scapegoat here. Being able to see exactly what changed is insanely valuable, right? If I'm working with a teammate and I know he's new and I've been doing this for a while, every time he makes a pull request to request changes, I can go look through all of his changes to make sure that his code makes sense and it won't cause any bugs. So, okay, so we've created our project on GitHub, but I don't have it on my computer anywhere. What do? You have a couple options. You can I would ignore the majority of these. I would either choose open with GitHub Desktop or download zip. So, if you download it as a zip, it just downloads everything in the project folder, but doesn't give you the layer of Git that tracks the changes. If you open it with GitHub Desktop, it'll open up GitHub Desktop and it'll say, okay, this is the URL for your project. Where do you want to store it locally? The default folder will be in your user, documents, GitHub. We'll leave it there. And once you hit clone, let's take a educated guess. What does clone do? It makes a copy of the project, right? Where does it copy it to? It copies it from the server to my machine. So if you haven't done any sort of web dev in the past, some of these terms might start to get a little scary. Server, for example. However, I'm going to try and keep this in layman's terms. So cloning in this case helps you delineate what's the client and what's the server. The server is github.com. I am the client, right? So I'm copying the files from the server down to my computer. So when I hit clone, we'll wait for it to download. And if I just go ahead and open the Windows Explorer, Windows E is my little hotkey that I use for that, and we go to my GitHub folder, you'll see my fun Unity project, right? And if I open that guy up, we'll see my 3 files that we had previously, but you'll also get this .git folder. And this .git folder is what makes any regular folder in your project a repository instead of just a regular folder on your hard drive, right? If you can't see the .git folder, you have to go to View and Show Hidden Items. If you go try and look through it, it's going to be a little hard. You may be able to go to Google and type in how does the .git folder work. We're not going to cover that in this video, but basically all this folder is doing is tracking all the changes that have happened to my project. But now that I have downloaded the changes and I have that .git folder, GitHub Desktop can go look through that .git folder, and oh look, it can even see the history that I've made, right? It can see that I'm on the main branch, and here are the 2 changes that have happened to the main branch. So, we made a change on the server when we updated the README by hitting this little edit button. Let's make a change locally, right? So let's go to Documents, GitHub, My Fun Unity Project, and let's just go change the README again. Or, you know what, we'll make a new file. We'll just go new, I don't know, let's create a text document, and we'll call it temp for temporary. And we'll open that up, and we'll just say my temporary text. And we will hit Control S to save, and we will close the file. So, you see our history hasn't changed, but that's because we haven't made a commit yet. If you go to the Changes tab, you can see, oh, my one change is temporary.txt or temp.txt, and you can see the line that has changed. So I need to do the same thing that it prompted me to do on GitHub, which is add a description and then commit, right? So we will say create temp.txt, and we will hit commit. Okay, so now you might assume I've made a commit, other people should be able to download my change, right? If I go back to GitHub and I go to the history, oh crap, we only have 2 commits. Why? Well, I've made the change on my computer, but the server doesn't know about it yet, right? So how do we let the server know that we've made the change? Well, GitHub Desktop is smart and it goes, oh, hey, you have 1 change that needs to be pushed up. And if we go to history, you can see it has this little arrow here letting you know that this guy is on my computer, you need to push it up to the server, right? So if we hit push, we let it finish its little operation, and we refresh our page here. Aha, the server knows about it, right? So at this point, my buddy could go download the project on his computer and he would have my entire history, right? So a workflow idea here is that as I'm working on things, I could keep them locally, right? Like you may be thinking, oh, cool, if I'm working on something and I'm making stuff that might break, I'll just keep the changes locally. Okay, that's why branches are important. Because you're going to want to keep things locally because you don't want other people to have your code that doesn't work right now. But you always want your you always want your code on the server so that way you never lose anything. So this is where branches come in handy. And making branches is super easy. I go up to the little branch dropdown and I click new branch. And let's give our branch a decent name like feature/add new file. And now if we go back to our project and we try and look at our branches, we only have main, right? So yet again, our change was only made locally. So you can see here, I can publish the branch. And once I publish the branch, if we go back to the website and we refresh, I made a mistake. maybe we go to view all branches because I haven't made any changes yet. Okay, so it didn't pick up in that dropdown because I haven't made any changes that it was like, okay, you may want to know about this branch in the main list of them. So you can see this is a branch that I am able to use. So at this point in our little diagram here, we have made our first branch, right? So if we go add some changes to it, let's just go to our folder structure and we'll add, we'll call it branch 1, and we'll just add some gobbledygook to it, and we'll hit save. And yet again, we'll just let it do the default commit name, so create branch 1. Usually you want your commit names to have something reasonable like updated player movement speed or fixed bug that prevents text from showing on screen, something that explains the change that you're making. So that way people don't have to go look in the files to get a general idea of what happened. So I'll go ahead and commit and push. Okay, so if we look at the history now, we have our new create branch1.txt. However, if we change branches back to the main branch, that change doesn't exist, right? These are timelines that do not sync up anymore. I have diverged, right? My timeline when I broke off kept these 3 changes, right? So if we go back to our little diagram here, let's clean it up a little bit. I have 3 circles here on the master timeline, right? Representative of initial commit, update the readme, and create temp. And then I branched off here, right? And I made a commit on this branch, right? So let's say now at this point, I want to merge this change back in. How do we go about that? You can do it through the GitHub desktop UI. If we go to, it's smart enough to know that we've made changes. So you can see here, create a pull request from your current branch. If we just go ahead and click this button, I believe it pulls us to GitHub. And okay, so now the UI might get a little confusing. There's this little arrow here, right? It's saying, I want to merge the thing on the right into the timeline of the thing on the left, right? So I want to merge my new branch into the main branch, which is what we want to do, right? So now we could give the pull request a name, and you could say, whatever the whole branch was about, and you could leave some comments saying, hey, this may not be a final change, for XYZ reasons, would you please review it? And at this point, if you're on a team, this is where you could click on this dropdown, and if you have people on your team, you could select people to review your project, and they would get an email notifying you that, I need to go check out these changes. So if we go ahead and hit create pull request, now you can see if we go back to our code, we get this little highlight. Oh, hey, there's one active pull request. So let's pretend let's pretend I'm my coworker and I need to go review his pull request. So I would go into the pull request. I would read the title. I'd read any description they provided. And then I would go in and I would look at the files that have changed. And I'd say, okay, this looks good. I'd hit review changes. And I can't hit approve here because I am the user that created the pull request. I can't approve my own thing. But if I was somebody else, I'd click approve and then I'd click submit review. And once I've gotten that review, typically there's some sort of workflow in place that you'll see here in a second. This is trying to figure out whether or not we can automatically merge. We'll see if we refresh if that goes away. We will talk about something else while that's waiting. So we have successfully created our project. We've done some work, and we've merged that back into the main branch, pretending as though we were a developer working on a multi-developer team, right? That is the absolute core of how Git and GitHub interact, right? The only thing that you're going to miss then is if I'm another user that's acting. Hold on, let me rephrase that. If you have another person on your team, how do you get their changes, right? So let's say somebody else had done that pull request, and once this merge button is ungraded, I'm not sure why GitHub is taking so long. You'd hit this merge pull request button, and what that would do is it would do this operation here, right? It would combine the timelines, taking all of the changes that you've made and applying them on this timeline. I'm sorry if my circles are terrible. I'm terrible at painting with a mouse. So now that I'm the other person that didn't make this change, I would have to go to the main branch and hit fetch origin, right? And that would download any changes that my computer is not aware of. So the core workflow here, right? You create your project, you would typically add your Unity project to the initial commit, right? Then you would branch off to do your change. You'd do all your changes, and then you'd merge your code back into main. When you're done, you'd pick up a new ticket, you'd branch off, you'd do your changes, you'd merge back into main. And then every time you merge back into main, you'd want to make sure that you pull so that way you're on the latest changes, so that way you have your changes from your fellow developers. Okay, I feel like I've been rambling for a little bit, and this guy still isn't loading, so I think we're going to end the video here. If you have any questions or if something wasn't clear enough, feel free to put a comment in the video, and I will address it in a further video. Thanks for taking a look.